Alright, this is the FPGA project system on a chip that Jesse Cooke and me, Greg Smith, worked on for the semester. It's based upon the Spartan 6 FPGA on the Atlas platform made by Diligent. As you can see, we have a touch screen, and then we have the Atlas board right here.
Switching over to the block diagram, it shows all the innards of the FPGA that we programmed and loaded in. We got the microblaze, which talks over the RS-232 to the computer, and that also controls the touchscreen. The VGA controller is displaying an image on the LCD display, which is just being read out from a RAM. And all the buttons and keys on the display, the CPU will process every time you hit one of them, and it'll send a GPIO signal to the audio subsystem, which will read audio samples from flash and put them through the audio processing blocks. The loop button will also read a much longer file in from the DDR block, and that will play at the same time.
So when we boot the system up, it takes a few seconds to load the bit file into the FPGA. The system comes up, the LCD screen comes up. It takes 20 seconds to transfer the data that we stored in flash. It gets transferred over to the DDR memory. Once that loads, these two lights come up and tell you that your system's ready and ready to play with. It'll come up in a second. There you go. This is our music production center that we designed all on FPGA. You can see right here the touch screen, which gives you sample triggers just like a AKAI MPC, where you can individually trigger one-shot hits. You can control the slider down here controls the cutoff frequency. It's got a low pass, adjustable low pass filter, so when I sweep my finger down here, you'll hear the frequency change for the sample. So the keyboard portion of our design basically has a frequency shifting algorithm that there's 3 different samples mapped to the keyboards, and each sample is mapped to 4 keys. And the first key will play the sample at full speed, the second key will play the sample at half speed, third key quarter speed, and fourth key A speed. So you can hear what kind of one sample sounds like frequency shifted. And then the next sample that we have is on this the next 4 keys of the board. And then the last sample is mapped to the last 4 keys.
Right, 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 right.
So to implement looping on our board, we basically took the flash memory in the beginning, the first 20 seconds when the board boots up, and we dump it into DDR memory, and the DDR memory into the AC97 IC is a separate channel, so that can be driven independently of our sample channel. So we can activate the loop by pressing this button, while at the same time coming through the right channel we can trigger sample shots. And we can also do the keyboard algorithm where it does the frequency shifting. Alright, the looping on the board works like this. You hit this guy, this loop key to start it. You hit this key over here to go to the next loop. That'll play when this loop is finished at the exact time. This loop will just continuously keep looping until we hit this key again to transition to the next loop. We'll let it loop one more time and we'll do it. Now it's going to transition to the next loop. And then if we hit the loop key, the whole system's going to stop at the end of the loop. Same time we can trigger samples. One of the coolest things that we implemented in this project is a record and playback feature. Via the 232 interface, we can trigger a command that will record the sequence of triggers that we play. So hit the record button. Now we can do a little beat. And then we can play it back with another button hit, and I'll play it back in a loop.